Hello, everyone, and thank you for joining us for today's LuxpowerTek webinar, Practical Guide to GenPort and Parallel Configuration. Just a few quick items before we get going today. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, feel free to use the Q&A button at the bottom of the screen to type in your questions. They will be monitored. This webinar will be recorded and shared with all of you within a few days. And it is my pleasure to introduce today's presenter, Andy Daniels. Andy is the head of LuxpowerTek South Africa, bringing 8 years of expertise in the solar and energy storage industries. Based in South Africa, he also serves as technical manager, overseeing business development and service operations across South Africa and other English speaking markets. Without further ado, I'll pass it over to you, Andy. Thank you.
Thank you very much, Tatum, and it's such a pleasure to be back again, speaking to your clients. It's wonderful to be able to share our knowledge with you. So, as Tatum said, today we're going to be speaking about the GenPort function as well as the parallel function on the LuxPower, the LXP range, which charge solar cells across Canada. So, let's get into it, right? So, in the previous session, we covered the monitoring section. And if you weren't able to attend that, you can always get the recording from Charge Solar. Just reach out to Tatum. She'll be able to help you with that. But today, in particular, we're going to be speaking about the LXP range and also the other models that that are sold in Canada. And we're going to be speaking specifically about the generator port as well as the parallel functions. All right, so it's the gen function as well as the parallel function introduction. Okay, so all of our machines that are sold in the US and Canada, you'll have an AC input, you'll have an AC output, but you'll also notice that the machine has a generator port. And it's quite cool to know that the generator port has multiple functions. It can function as number one, as exactly as it is denoted in the screen printing on the machine. It can operate as a generator input port, meaning that you can have a generator or connected there for an emergency power supply should the grid go down, or if you are in an off-grid situation where you want the generator to assist with loads or to charge the batteries. You can also assign it as an AC coupling port, meaning if you can retrofit your LXP to an existing grid-tied solution, and you can take a feed from your existing grid-tied inverter and you can plug it into the gen port, and in the settings you will just assign it as an AC coupling. And then the final one that you can do with it, as you can set it up as a smart load port. Now, smart load port is really, really cool because it allows you to use that particular port as an auxiliary output, meaning that your inverter will have two outputs. It'll have the standard EPS output, and it will also have the gen port, which we assigned it as a smart load, and it'll put out power on the smart load port. So we will go through each one of those uses in detail. All right. And obviously this just gives you enhanced resilience. As the slide says there, it's independent generator port enhances resilience and ensuring that you can match your inverter to your requirements. So the first one we're going to look at is the generator port, right? So if you have a look at this picture here, and this is actually a little video that will play, but you can see here that we've got the generator symbol here, or the little icon for a generator. We got the generator plugged in to L1, L2. So very important for you guys, especially in the US and in Canada. The generator that you use must have a center grounded output so you have, obviously it's two hots, right? So you have hot 1, hot 2, or live 1, live 2, and then your neutral will be on the center tapped out. So that's very important on your selection of a generator. Obviously, they'll be selling all of those in Canada, but just in case somebody asks, it has to be a split phase generator. All right, so it supports center grounded generators, 240 and 120, and we recommend a generator that is equal to or greater than 5 kilowatts. Why do we say that? Because when you're running the generator, when you're using your inverter in an off-grid situation, and you might have bad weather or you might have a poor solar day, and your batteries need charging and you run the generator should then take by way of design, the generator must be able to take all of the load that's connected as well as charge the batteries. Now, taking the load will always be the priority. And then if there's any surplus power left, it will be used to charge the batteries. So we will show you how to do that in the setup, where you can control the power that the generator assigns to charging the batteries. We also have, if you have, let's have a look, see if we've got the dry contact ports here. But yeah, so it's got the dry contact ports here. And the dry contact ports you can use to remote start a generator. So if you are using a generator that has an auto start function, then you can use the inverter logic to start and stop the generator according to your requirements. We also recommend so in here we also have an input breaker, but we also recommend that you have the generator breaker at 90 amps. The generator, like I said, it will prioritize EPS loads, and the battery charging will be secondary. And the cool thing is that on our monitoring page, especially on the mobile app, you have a Gen Start button. And that's pretty cool because now you have access for very quickly on your mobile phone, simply by logging into the app, you'll see a Gen Start button. And if you click it, it will automatically start the generator according to how you've set it up. But you have to have an auto start generator. Obviously, it cannot start a generator, by mind power. And then the generator input port supports AC coupling and obviously smart load connection, like we said. Right, so this little diagram here, the single line diagram, just shows you how our logic works on the generator. So I just want to move this out of the way. So here you can see we have the generator, it goes in, you can see that the contactor is open. And when the logic allows, this contact will close. Now remember that if you're using your generator port as an input port, our inverter can only support one type of AC input at a time. So in other words, if grid is available and the generator is running at the same time, both the relays cannot open at the same time. So as a safety feature, only one of them will be working, and it'll prioritize the AC input from the grid first. So let's put ourselves in a situation where the grid fails, or you're in an off-grid situation and your inverter starts the generator, then this contactor will close, power will come through, it'll supply the loads, and any surplus power that comes through will be used to charge the battery. Okay, and then just remember that the maximum input current can be 80 amps from the generator side, and we also have to take care that we don't overload the generator. And this is also an important thing to explain to your clients, and each one teach one. So the knowledge sharing goes like this: your generator, as you know, has an alternator that puts out power, and most generators will have a voltage regulator on it as well. So once the generator starts, you will need the automatic voltage regulator to settle down so that it can put out the right voltage, number one, and the right frequency. So this relay here will not open until those requirements are met. In other words, the voltage has got to be within range, as well as frequency's got to be within range. And only then it will open up. And sometimes we have customers that have a generator that is too small or that is too old. And what we tell them to do is connect a load on the generator itself so that the voltage regulator can settle down and get the voltage in the right range or the frequency in the right range. It's just a trick that we've learned, and it works really well. Okay, so the basic function for the generator charge settings, you'll notice that on the gen charge function settings on the settings page of the maintenance page, there is a specific tab where you can drop down. Here you can drop down the gen function, and here you can see there's generator, there's AC coupling, AC coupled dark start, and smart load. So you can only use that port or the logic for one of them, right? So it depends on which one you're using it for. This is what you'll be setting here. So in this particular segment, we're going to be talking about the generator. So you can set the battery charge current limit, and that's quite a cool thing to have, because over here, you can determine what power you're going to be assigning to battery charging. So for instance, you might have a 10 kilowatt a 10 kilowatt generator, and you want to limit the charge on your batteries to 2 kilowatts because you know that your loads could be anywhere from 0 up to 8 kilowatts, then you can actually set the maximum amount of charge power that you are allowed to give the battery at any given time. And that will allow, obviously, that will make sure that the generator is not overwhelmed under load. So you can set the charge limit by setting the charge limitation from the generator. And then obviously, once you've set this, the inverter will adjust the charge current to avoid overloading the generator. So for instance, if you, it will always give the difference. It'll always see to the load first, and it'll minimize the charge to the loads, to the batteries until the loads minimize, and then it will increase it again up to the maximum. All right, and then if the generator rated power, if the load is greater than the generator size, then the generator, it will allow an overload of generator capacity plus 500 watts for 1 minute, and then it will report a generator overload warning. So we do have some fail safes in place to ensure that you don't damage your generator. Okay. And I'm going to mention it a little bit later on in the presentation as well when the slide does come up, and I'm going to mention it now as well. It's very, very important for you guys in at Charge Solar, who assist clients with setting up, as well as the installers that do this, to make sure that when you use the generator port with the generator plugged into it, that you do not inadvertently set it to smart load function, because it'll put power out on there, and we all know what happens when you do something like that. It'll make it'll damage the generator. A puff of smoke will come out of it, and not out of the exhaust, in another area, and it's very difficult to get that smoke back in again. Okay, so here we have the dry contact connection. So remember, I told you a little bit earlier on that our inverter supports auto starting a generator. So on the communication board inside the inverter, which is over here, you can see it on a sort of a little bit of a distance away. You can see the whole connection point of the inverter here with all your voltage connections here, your breakers there. And here is on the left-hand side, you'll see the control board. The interface board, sorry. So on the interface board, here is a zoom in on the interface board. You can see that here we have the dry contacts for the generator. So and it's basically just a relay. That's all it is, right? And we have 3 contact points there. So you'll have normally open, we'll have the common, and normally closed. So depending on how your generator start feature works, you might need a closed relay, and then when it opens, it starts a generator, or you might need it the other way around, that it's open, and when it closes, it starts a generator. So you have to, so it's literally just a switch. That's all it is, right? And you have to then run a signal voltage through there. So the voltage can either be in DC or in AC. And the limitations for that are that if you are running it in on the dry contact, you can run a signal through there up to a maximum of 250 volts AC, but your limitation is 5 amps, okay? Because the switch, the design of the plug point cannot carry more than 5 amps. And if you are running a DC signal through there, to start your generator, then the maximum voltage that we can run through there is 30 volts DC. And then obviously the maximum input power or input voltage, a potential difference on the generator port, input port, is 280 volts AC and 80 amps. Okay, so here we have a look at the logic. So basically, when the grid is on, the inverter won't start the generator. When the grid is off, as a matter of fact, I'm going to change that statement. There is a time when we can start the generator when the grid is on, but I will get to that in a later part of the presentation. But when the grid is on, typically the generator will not start, right? When the grid is off, in other words, when it goes to off-grid mode, the system will run on solar power, and it will run on battery power as well. Now you have got to set the criteria or the flags for when the dry contact will work to start your generator. And now we're going to deal in this part. We're dealing with a generator that has got an auto start function. So you can set the battery off-grid cutoff voltage. So in other words, you can set the flags for when the battery's at the lowest point, when it must start. So if you've set it, as you can see in the sample here, we said the start voltage SOC is 20% right here. So what it'll do is when the SOC gets to 20, it still runs on battery. The minute it triggers to 19%, which is SOC cutoff -1, then it will trigger the gen to start. The generator will start. and the generator will automatically then take over the loads, and it will charge the battery according to the charge current that you've allowed. And then as the battery is charging, the charge gets up, and you can have it. So this will be your start flag, this will be your end flag, and when it gets to the end, plus 1%, it will switch the generator off. And so those are the cool flags that you have there. And then you've also got some start and end times. So it's got to meet these criteria. It's got to meet the criteria of start voltage or SOC and stop voltage and SOC, and within these two time frames here. So you can actually set two different time zones for when you are willing to run and start your generator. You might have noise limitations in the area that you live in, or you might have any other criteria where you can't run your generator. So you can set the flags on SOC, voltage, and time. Okay, so the generator will start when the battery reaches the off-grid cut-off voltage SOC, or if the battery sends the charge request from the BMS, or if the battery doesn't allow discharge, or if the battery reaches the generator start voltage or SOC, and within the generator time. So there's quite a few criteria that you can choose from here, and you can tailor make the generator start feature to suit your needs. And once again, I've got to reiterate, this is only for generators with an auto start feature. If your generator doesn't have that, then you've obviously got to get up, or your client's got to get up and go and start the generator himself, and maybe he's got to put the ATS over from grid to gen as well. So if you don't have a fully automated system, then we can assist you with. If you don't have a fully automated system, you've got to get up and trudge through the snow and start it yourself. If you do have one, it makes things a whole lot cooler and a whole lot easier. And obviously, then you can do the setting from a remote location. The inverter will stop the generator when the battery reaches the system charge voltage end, or the limit, like I said over here. The battery doesn't allow charging anymore, or the voltage of the battery allows discharge, or the battery reaches the generator end charge voltage, or the set time, as I said. Now, if the generator does not support auto start function, like I said, it's got to be started manually. The battery will charge until the battery voltage SOC exceeds the charge end limit. And, I mean, that's self-explanatory. Okay, but this is a pretty cool feature, and the format that I'm showing you here is on our new working mode display. So when you log into the maintenance section of our user interface on the web portal, this is web portal that I'm showing you, right? So if you log into the web portal, in the top, you can have the old setting page, and you can also have the working mode setting page. So what you're seeing here is the working mode setting page. You can use either one of the two, whichever fancies you, but you can set them. Both of the settings pages have exactly the same features. All right, so let's have a look at the logic. So if the generator dry contact starts when the generator starts to work, obviously it gets triggered by either by the voltage, right? And then after 2 minutes, so what we have here, I'm going to move this to the one side. So what we have here is we have a generator warm-up feature. So we're assuming that you've got a generator with a cold that's starting from cold. So it has a warm-up feature, and probably in this time you might not, if you don't have enough solar or battery, or there might be no solar and you've got off battery and it starts the generator, the relay which allows the power in will be open in the startup phase. So it allows the generator to warm up, and then once after 2 minutes it'll close, and then the generator obviously starts inputting power from the generator, and it'll take the load first as a priority, and secondly it will charge the batteries as we discussed, and then it just goes through this loop. Has the battery reached the cutoff voltage yet? No. Or the SOC? No. And until it gets to that point, when it does, goes down to here, and then it will open the relay again, or the contactor, so that no power comes in from the generator, but the generator will still run, and it'll go onto a 2-minute cool down feature, and then from there it'll use the dry contact to switch the generator off. And like I said, this feature is only for generators with an auto start function. Okay, and then here you can see on the gen function, you can actually set the generator cool down time here, which is a pretty cool feature, so that you don't damage your your generator in the long run. Right, so generator boost. That's a pretty cool feature. It's like a turbo boost, right? I mean, it does exactly what the name suggests. So generator boost, I'll give it to you in layman's terms. If you have solar connected, then solar can assist. That's basically what it means. So the gen boost function will only work in the presence of solar. Now, in previous models and previous iterations of our firmware, we protected the generator in such a way that if there was solar available, solar charged the battery and generator took the load. Then in our later models, and all of the models that you guys have in Canada at the moment have got this feature in it, we fitted an internal CT or current transducer to the generator input live, right? And so it can measure current flow on there. And there's a purpose for that. Number one, it can give us an indication of how much power is coming from the generator accurately. But the second feature that it has is a pretty cool feature. It's a safety feature, and it means that we can now use solar to supply power to the loads as well without exporting power to the generator. As we know, that could be dangerous for the generator. So from the time that we've added the CT onto the main board where the gen comes in, we've now allowed to have this gen boost function. So if the maximum generator input power is greater than or equal to the load power, then the generator power will be prioritized to meet the load. And any surplus power, while the PV is not surplus, the generator will charge the battery. But the opposite is true, that if the generator input power is less than the load power and PV is available, then PV will assist to charge the batteries as well as take some load. It's a pretty cool feature, but you've got to enable it here, okay? So it's something that you can choose to enable or not. Right, here's the one feature that I mentioned right in the beginning. It's the weekly gen exercise. So what you can do is we've added a new feature to our user interface where if you have a generator on your client's installation and you might have a very stable grid for a very long time, so you want to make sure that your generator gets exercised or started up and run on a regular basis, then you can set this remotely. So you can set the function and the basic aim is obviously to maintain the generator by testing it weekly. And the test takes approximately 20 minutes to complete. And during this time, the generator will obviously auto start and auto stop. But remember what I said right in the beginning, that the gen only works in off-grid mode. Well, this is the only time it will work when the grid is available. So the only difference being that the gen contact will not close. So that it'll start the generator, allow it to run up, do a test for 20 minutes. During that time, it will even get, the power could be used to charge the battery. And then after 20 minutes, it will allow the generator to go into a cool down cycle and then shut it off. So that's a pretty cool feature to have for clients who have a permanent generator on site and they'd like to exercise it from time to time. So you can set the frequency on that as well. Right, AC coupling. So now we're jumping to a next feature of the gen port. So the AC coupling basically means that you can either retrofit your LXP to an existing grid-tied solution, or you can have a customer who wants to use additional, he wants to put up a grid-tied inverter for additional ability to charge batteries. So you might have a very, very big battery bank, and he wants to dedicate the maximum power to charging the battery. So basically what you can do then is you can put up a grid-tied inverter, which is grid connected, and then we also have a connection that runs to your LXP or your LuxPower inverter. It goes in on the gen port, and then on the settings port, you're going to set it as an AC coupling. And the AC coupling port then also uses the feature where it sends the trigger voltage to the contacts to wake the grid-tied inverter, and it also supports frequency shifting. So in other words, when the batteries are fully charged and you've got no export set for the grid-tied solution, then it can slow down the production of the grid-tied inverter and eventually, just by frequency shifting, shut it down. So it's compatible with the existing grid-tied system, supports parallel grid and battery operation via the gen port. It prioritizes a grid-tied inverter power supply and charging when the grid is lost. Okay, and then the SoC based on and off control is recommended that this is your start SoC and this is your stop SoC. All right, and here's a little, there'll be a video in this little presentation here. I'm not going to run through it now for time constraints, but these presentations are given to Tatum, and she hands them out to anybody who would like it, and it's free of charge. Right, so the next one we're going to look at is the smart load. So this is the final feature that the Gen port has. It's a smart load function. So what does smart load mean? Smart load means that you now have an auxiliary output on your generator input. And it allows you to be able to split loads. I'll give you a perfect example. So we typically like to have loads where we can differentiate them by calling them essential loads. And then within the essential loads, you can have sort of loads that are not really that essential, but they'd be nice to have if the grid went off. Right, so typically here in South Africa, what we'll do is we will put all of the light circuits and all of the socket circuits, the wall socket circuits on the essential loads. And then on the smart load, we will add maybe the water heater, maybe if you've got underfloor heating or you've got a pool heater, you'll add it onto that. And then simply what happens then is so I'm going to speak in two different features. In off-grid mode, what it'll do is it will check to see the criteria that you've set. If the solar power and the battery SoC is within the range that you've set, then it'll put out power on the auxiliary port as well. And the minute either PV drops below the value that you've set, or the SoC the SoC of the battery drops below the preset value that you set, then it will cut power to the auxiliary power and only put power out in the EPS. However, you can also enable this feature to be permanently on. So in other words, you can have power output, you can have power coming out of the load side and out of the gen port when the grid is on. And I'll show you in the next slide how you can enable that. Now remember at all times that if you have, I'll use a 12 kilowatt inverter. If you have a 12 kilowatt inverter and you've got loads connected to there, the combined value of the loads on your smart load and your EPS output can only equal 12 kilowatts, right? You don't have 12 on one and 12 on the other, right? So by utilizing the gen port, you basically, in an off-grid situation, you're basically going to be splitting your output between these two, depending on what size loads you have, but it'll always prioritize the load port. Obviously, that power stays on. So just as a note, we do have customers who ask that. Do I get 12 out on each port? No, you don't. It's a shared output, and it runs at the maximum of the rated output of the inverter. Okay, so let's jump to the next slide. Where's my mouse? Okay, there we go. Oh no, I didn't want to do that. Right, so the parallel function, this is a pretty cool feature. What does parallel mean? Parallel means that you can use multiple inverters. So you can use 2, 3, 4, 5, any number up to what the limitations are. And here it says supports up to 10 inverters. And you can create a multiple inverter single phase parallel. So in other words, you can take, let's use a 10 kilowatt, for instance. So if I put two 10 kilowatts together in a single phase installation, I get a 20 kilowatt output, a 30 kilowatt output. Or what you can do is you can take two inverters, split phase inverters, and you can create a 3-phase output. Can you believe it? A 3-phase output with two inverters. And we have in the manual, it'll show you how to do the wiring to get 3 phases out of 2 inverters. Or you can simply use 3 inverters, so in other words, 1 per phase. And then you can use multiple inverters on each phase to get a bigger capacity output. We've done that many, many times. For instance, you can have 3 inverters on each phase, 3 for the R phase, 3 for the S phase, 3 for the T phase. Or what you can do is, if you've done if you've analyzed the loads at your client's site and you determine that one of the phases runs at a much higher capacity than the others, then what you can do is you can increase the capacity of inverters on that phase. For instance, you can have 1 on the R phase, 3 on the S phase, and 1 on the T phase. It works, and it works very well. So here we have a single line diagram. And the single line diagram is quite descriptive, and it shows you exactly how to connect multiple inverters in, excuse me, in a parallel system. And like I said, you can do it in single phase and in three phase. It's very important that when you do the settings or the setup, that you determine in the settings whether it is a single phase parallel feature system or a three phase system, because the master inverter will control the output of all of the others. Remember that we have to match the voltage sine wave. They have to overlap each other perfectly, as well as obviously the frequency. And the load sharing has to be done correctly as well. So it's very important that when you set up a multiple inverter in parallel, that you assign it correctly. And so there are a few critical things. Number one, your outputs will be connected together. So in other words, your hot one and hot two will be connected together. And you have to, that's on the power side. On the AC side, on the input side, they will also share from the same source. And then the paralleling. So the paralleling will work. You'll see here we have a dotted line going between the inverters here. So this basically just shows you the bottom of the inverter, right? So here we have the parallel ports, right? So you have to, you'll notice that we create a closed loop system here. So we start there. Let's start on the left side here. So from inverter number one, we go to inverter number two. Then from inverter two, we go to inverter three. And then from inverter three, very important, we have to loop all the way back to inverter one. Why do we do this? Because we're using CAN bus communication protocol. And so we have to close the loop, right? And it's very important that you do that. That's the first part of it. And the second part, obviously, you see these dip switches here, these dip switches. So if in a multiple inverter situation, the first inverter will have the dips on, all the ones in the middle will be off, and the last one will be on. So the first one in the chain is on, the last one in the chain is on, and all the ones in the middle, their dip switches are off. Okay, and in this particular infographic here, you can see that they are using a shared battery, which I highly recommend. And so the battery is shared, but very importantly, guys, we've had this question asked once or twice. You cannot, never ever share PV. Okay, so in a multiple inverter setup, each inverter must have its own solar input. Never ever share the solar between inverters. Very dangerous. Right, so it's shared battery, independent PV. You've got your dip switches set correctly. You've got your communication cables running in the parallel correctly. And then you followed your wiring according to the diagram and according to your local regulations. In a single phase setup, only the master inverter will use the CT, the grid CT, to monitor the grid. And if it's a three phase setup, then you will use three CTs. So each phase, so if this was a three phase installation here, then each inverter will have a CT, and the CT will go onto the hot of the phase that it is running on. And I think I explained this in a previous training session as well, that our inverters are grid following, right? So when they connected to the grid, especially in parallel like this, you've got to make sure that a single phase parallel are connected to the same input, so that because they follow or they copy exactly what the grid is doing. So they will follow the grid voltage and they follow the grid frequency as well for their output. It is only when the grid fails that the inverters will go to pure sine wave. And while they're in pure sine wave, they will then follow the output signal from the master. The master will control all of those things. Okay, so each inverter must have its own PV strings, and it's all everything is written here exactly as I explained it. The infographic is pretty handy to follow. It's color coded, and these diagrams that I'm showing you here on the presentation, these are all inside the manual that is supplied with the machine. Typically here in South Africa, they throw the bloody things away. They throw the manuals away before they even read it. Sometimes they throw the dongles away too, and they'll tell you that I don't understand what it is about people. First thing you do, open the box and throw the manual away. Right, so here we have a three-phase installation, which is exactly as I spoke about earlier on. So here we have three inverters. Each one is on a separate phase. Same, the settings are exactly the same. Here you can see they've got a shared battery bank, independent PV inputs. First and last dip switches are on, the middle ones are off, and then each inverter is connected to an individual phase, right? And just remember that your CT, each machine then will get a CT, and the CT will be connected to the phase that it is, the CT will clamp onto the phase that that particular inverter is connected to. And I mean, here we are using R phase, S phase, and T phase. So, and this explains exactly what the inputs are. And the supported phase types that we do is 208 120 or 220 127. And you can, as a matter of fact, when you do your settings, you can actually select that in the drop-down menu. You can select what your particular connection is. Our inverters automatically detect the grid voltage and frequency, but you've got to set this for the output. Okay, you've got to make sure that you set this for the output, and that obviously depends highly on your the location that you're installing at, what the requirement is there. All right, I can't see the top here, so let's just move it. Okay, it's the three-phase parallel setting for three inverters. So this basically just shows you. So this is a screen grab of the maintenance page. So here you can see we have changed the role here to three-phase primary. So there's a little arrow there. If you click on that, so when you do this, you're going to set each one individually, right? So you have to go, you're physically, if you're doing it on the user interface on the web portal, you've literally got to select inverter number one, and you've got to assign it a role. So you're going to assign the role there of three-phase primary, and you'll tell it it's on the R phase. Then you go to the next one, you're going to set it as subordinate, and all of them will be subordinates after that. And then they know that they've got to wait for the logic to come from the three-phase master. All right, and then if you are setting up your bank with a shared battery, then you've got to set it here. That's also critically important because it allows the charging authority from the inverters to know exactly that it's a shared bank, that they will be controlling one battery bank to charge and to discharge. I like using a shared battery bank because you might have a situation where you have one phase that is quiet, or that is underutilized, and you have one phase that has a higher load capacity. Then it's got access to the whole battery bank. Because if you remember that if you set up your system where you have independent batteries for each inverter, the minute one battery bank gets to its end of discharge and cuts off, the entire system will shut down. Right? You can't have two inverters running with batteries and one's got no battery and can't put up power. It's a safety feature that we've built in. So in a three-phase setup, if one inverter has a problem, any problem that determines that it's not safe to operate, it will shut the system down completely. All right. So here we have inverter one set as a three-phase primary. The other ones are subordinates, and then we've assigned the phases. You can also, on here, you can also ask it to detect the phases, and it'll automatically detect the phases that you're connected to, because sometimes you go to an installation and you don't know which one is what's the R phase, S phase, and T phase. So you just connect them, you tell it to auto detect the phases, it'll detect it automatically. And then if you look at your output, and if you have a motor turning in the wrong direction, then you can simply swap the phases around. Simple as that. Okay. All right, let's jump to the next slide. See what we got here. Three-phase parallel with two inverters. There we go. That's what I said. I find this pretty cool. It's so you can set up a three-phase system quite economically using two inverters, just two inverters, and it's the way that we connect the outputs of the inverters. So the R phase, inverter one, you'll have L1, and inverter two will have L2. The S phase, you'll have L2, and the T phase will have L1. And when I first saw the diagram, I couldn't believe it. And then we set it up, and it works pretty cool. The output is limited though, but at least you have a three-phase setup with an economically available two inverters. Okay, right. And then here you're going in the settings. It shows you exactly how to do it. So you basically say 2 times 208 primary. So in other words, you're telling it here that there are only two inverters, and this is the output. So it's a 208 primary output with one subordinate. and then it will automatically assign once you've done the connections correctly, it will assign the outputs to the 3 phases. Split phase parallel system with 3 inverters. So just please make sure that each ports of the inverter are connected to the correct phase. Right, so basically what we're talking about here is obviously your live 1 and live 2. Make sure that you've got that correctly. And obviously on the output here, you're going to have a shared neutral. So we're talking about this is split phase, right? So it's not 3 phase, it's split phase. And this one you can see has a shared battery. Once again, exactly the same as we did with all of them. We set the parallel dip switches correctly. And we ran the cables from interlink them. We daisy chain them from one to the other, and then from the last one all the way back to the first. Okay, and in this case here, we're only using one CT to monitor the grid. And here we are supporting 200 volts and 100 volts in split, 220, 110, 230, 115, and 240, 120, depending on the area that you're in and the output that you want. Okay, so this here is obviously for your output on the in off-grid mode. Remember that you obviously have to set this correctly, but the voltage that comes through when the grid is on will always be grid following. Always whatever the grid voltage is, that is what it'll be. Here we have a split phase parallel system with 3 inverters. Like I said, on the LCD setting, you can simply go into the advanced features here on the LCD, and on the drop down, you're going to set that to 1 phase primary. And all of them will be on the R phase, right? And then you can also select shared battery if that is the case. If you have independent batteries, then obviously you're going to leave that unchecked. Right. But pretty much all of the other settings are exactly the same. And at any time of your setup, if you're unsure, give Charge Solar a call. The agents are free to help you. We have LuxPower itself. We have a support team that supports Charge Solar. We have tech support agents available 24/7, literally, and we're always available to help you. Because of how LuxPower distributes its product worldwide, there's always somebody that's awake around the world, right? The sun's always shining somewhere, which means there'll be somebody awake that can help you. In the US, we have Gilbert. He's based in Hawaii. And then we've got some people in the US. There's myself in South Africa. And then obviously the big team, the heavy hitters, they sit in Shenzhen, and they work split shifts. So there's always somebody monitoring the chat groups or the desk at any given time, right? So if ever you need help with setting up a multiple parallel system and you're not sure about it, give us a call or give Charge Solar a call. They will help you with preparing, telling you what to get, what breakers to get, how to prepare everything before you get to site, so that when you get there, there's no stress. I mean, that's the last thing you need, right? Okay, parallel system battery connection. So here we have independent batteries. And here we have a shared battery system. So the independent battery system, it's just battery to inverter. And here you have to run a communication cable from the master battery to the inverter. Here you have to run a communication cable from the master to inverter. And here you have to run communication cable from master to inverter. In this particular setup here, we have what's called a shared battery system with a DC bus bar. You can see the DC bus here. So all of the batteries are connected to the negative on the DC and the positive on the DC. And then they will be daisy chained in their communication. So you will have one master, and all of these will be slaves, right? And then you have only the master battery talking to the master inverter. So remember that. In this case, you need to have 3 masters and 3 communicating to each inverter. Here you have one master battery talking to the master inverter. And I like this setup here because if this one is underutilized, and these 2 need more power, they can sap from the whole bank. I like it. Right, parallel system inverter communication. Like I said, we use CAN bus communication, so we need to have a closed loop or daisy chain or a CAN bus node. So here we're going to set, here you can actually see we've got 4 inverters. So what we've done here is we've put this one on, that's off, and that's on, right? And then we run that, so we're going from here to the first one, to the second one, to the third one, and sorry, to the fourth one, and then from the fourth all the way back to the first. And that's how we close the loop completely. That's very important. If you don't do that, you're going to have errors pop up, and it's going to be a parallel error in a parallel system, or you could have a trigger error, something like that. So um, very important when you are building the system. Number one, make sure that we have guys that they do beautiful trunking below the inverters, and once you're running all your communication cables in there, you kind of don't know which end is which end. So it's handy to have a cable tester to send a signal down the line to see which one is which, because it's quite important that you follow this sequence, right? So that you go from this one to this one and then jump, and like that. You got to do that. So I always tell guys, number one, make sure that you use the cables that are supplied. I know that I'm almost sure the Canadian models come with parallel cables. Each inverter has got one parallel cable. And they're long enough to be able to build a setup like this. That's number one. So make sure that you use the parallel CAN cable. Number two, have a look inside these RJ45 plug ports. Just take a look inside there, shine a light inside there to make sure that there's no critters or no dirt inside there, or no we've had guys where they're working quite rapidly, and they're crimping cables, cutting insulation, and something drops inside there, and then they don't get proper communication. So if you're not getting a complete closed loop, just unplug them, have a look, and then also do some cable testing, recrimp the cables. And once you've set the dip switches and you've done the closed loop, it works like a charm, and it works for a long time, all the time. All right, parallel system monitoring setting. So remember that you can so this is on the device overview, right? So once you've built the station and you've set it up and you've added all of the dongles, you're going to go in, you're going to click on the station. And once you click on the station, it'll bring up all of it'll go to device overview, and it'll list all your inverters here. You can then go to the action tab here, and you can select parallel, but you've got to assign it a value, right? So we can have on parallel group A, we can have it A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. And then it'll group them all together. I've built a parallel system before in 3-phase where I had 3 groups. I had group A, group B, and group C. So all my inverters, I think we had 4 inverters on phase 1. So we had A1, 2, 3, and 4. And then we had 3 inverters on phase 2. So we had B1, 2, 3, and 3 on phase 3. So we had C1, 2, 3. And that way it'll allow you to see exactly in the drop down when you're looking on your monitoring, it'll be able to tell you exactly which group you're looking at and how they're performing. So that's how you assign the roles here in the setup, right? And I know it's a lot of steps to follow, but trust me, once you've done it once or twice, it's easy, really, really easy. Okay, so the parallel information display, you can see here, it will show, this is a typical LCD, and it will show you that the display looks like this. The information in the red box shows the parallel. Oh, no, I didn't want to do that. Go back one. Okay, so this here shows you the parallel number. So this one shows us that we've got 2 inverters here, and the inverter that you're looking at, it'll tell you what its role is, and it'll also tell you which phase it's on. And this is quite handy to have, especially when you are on site doing maintenance, as well as if you're working remotely, you'll be able to see it on the UI, the user interface on either your mobile app or on the web portal. And the cool thing about the web portal is, as well as the mobile app will change. This little icon here will change to a group of 6 inverters. And you can also click on the above where you see the serial number. You can click on that, and you can select which inverter you want to look at. It's pretty cool. All right, so we're going to jump to the Q&A phase now. I'm going to see if there are any questions in here. I don't see any. Tatum, I'm going to hand it back to you.
Yes,
If
I
there are any
do
questions.
actually see one question in the Q&A here. It just says,
Okay.
when multiple inverters are connected in parallel, how many
Mm.
dongle are set up for Wi-Fi communication? I
All
assume
of them.
just one,
No, all of them.
all
You
of
have
them.
to, yeah, you have to set up all of the dongles. So what you will do is, when you create the station, so in other words, when you go into, remember in the first demonstration that I gave you guys, I said there may be 50 ways to leave your lover, but there's only one way to set up a station on LuxPower, and that's from the logged out position. Okay, so you go into your app, or you go into the user portal and you log out of the app, and there's a registration button there. You can click that, and then it'll allow you to register a station on behalf of a client. You populate everything, and you're going to use. So let's just say, for instance, for argument's sake, we're building a parallel station with 4 inverters, right? So we take the first dongle, we register the station, and we use dongle number 1 to register the station. Then we go into the user portal, we log in, and then as an installer, you can look for that station. You find it, and then you click on the management, and you go to add dongle. Then you will add dongle 2, 3, and 4. And then you will go, once that's done, the station on the server is set up, and then you will go to building your station, and then you follow the dongle pairing the dongle with the Wi-Fi. You follow that step. So it's just 3 steps. Register the station with 1 dongle. Step 2, part of step 1 as well, add all the other dongles. And then step 2 is pairing the dongles to the Wi-Fi. And then once you've done that, they all come online. And it's important that each dongle is online, and that you set them all on the same server, because for monitoring and maintenance, it's important that we and you and your customer can see that. But more importantly, when you have a problem on site that you can't solve, and you are calling and asking Charge Solar to help you, or you're reaching out to our support desk, our techs need to be able to get onto each inverter to see what the problem is. It's also very handy to have when you need to do firmware updates. It means you can roll out updates to all of the machines independently. Yeah. So to answer your question quite simply, each machine needs the independent dongle.
Wonderful. Okay, we have another
Mm,
question here from
mm.
Justin.
Hey,
When will the
Justin.
off-grid inverters get the generator warm up and cool down feature? I may be mistaken, but I think only the hybrids offer this right now.
I am not able to answer that question. If Joe is still here, maybe he wants to. I don't think Joe can jump in and say that, but maybe Joe, you can, because I don't think attendees, or does Joe have the ability
I
to?
think Joe can, yeah, if he comes off mute, I think he can speak
All
to the
right.
group.
Okay, so if Joe's still available, I know Joe's actually in Puerto Rico at the moment, and I know he's also got a training session with a client today. So he did indicate that he may or may not be able to answer some questions, but it's an answer that I don't have right away. But we can get the information to Tatum, and then she can. Justin, it's a good question.
Yeah.
We'll get the answer to Tatum, and she can reach out to you and give it to you.
Perfect. I've taken that question down. And
Mhm.
then Justin also asks, will the inverter display the output from smart port and loads port separately so you can monitor the consumption of each set of loads?
At the moment, it doesn't do that. But we are working on that feature. It's a very, very good question, and it's a commonly asked. It's a common request that we have that feature where we can display, even on our display, on the monitoring display, or on the especially the monitoring display, where we can show exactly the power going out on each one. So we don't we the feature is being developed. I'm not sure if it's been rolled out yet in a beta phase, but it's a good question, and we're aware of it, and yes, it's being attended to.
Okay, great. We also have a question from Jimmy. This one sounds like a bit more of a scenario. So, on a single
Mhm.
phase, 4 inverters, no shared batteries.
Mhm.
If inverter 2 batteries are dead, will all 4 turn off?
So just run the question by me again. So it's a single phase parallel
Single
and
phase,
no
four
shared battery.
inverters. Yeah, 4 inverters,
Yeah,
no shared batteries. I guess 2 of the batteries are dead. Will all
yeah.
4 turn off
No,
is the question.
no,
Okay,
no, they won't. In a single phase, no. It just means that you have diminished output power then. Yeah. So the others will still work in a single phase parallel. The others will still work, yes. But obviously their capacity to output power will be lost. It will be cut by 25% because you'll have one inverter just idling, doing nothing. Unless, of course, that inverter does have solar available, and you have, but obviously if there's solar available, then obviously it should be able to use the solar to charge a battery, but no, it won't. It won't shut down the system. No, the system will
okay,
run. It's only in three-phase parallel that it'll shut down.
okay, great. We have another question here. How will the new Lux Power Power Hub handle different size inverters?
Once again, that's a question that's beyond my
Okay.
capacity. It's a question that it's a good question. The Power Hub has been developed specifically for the US market. It's, I know that it has been launched. I was part of seeing it kind of initiated in the end of 2023, and the development ran all of last year and obviously this year. But to answer that question, that's another one of the another question that Joe will have to get back to Tatum with, and she can reach out to you guys and just put it out in a bulletin. But it's a very good question. Thank you very much.
Okay, so there's no other questions in the Q&A. If anybody has any last ones, please type those in. Andy, thank you so much for your thorough presentation, and thank you to everyone who joined us today. This is the
It's my
second
pleasure.
webinar in our three-part Lux PowerTech webinar series. So if you missed the previous webinar, which was on the app and web monitoring, you can find it on our YouTube channel. I'm just going to link it in the chat here. For everyone. And then our next webinar coming up is on Tuesday, November 25th. And this is on basic troubleshooting and working modes. So, yes, I don't see any questions have come through the chat.
All right. So open, answered. Oh, there we are. Okay. I didn't see. I see Joe has answered some questions
Yes.
in the chats. Yeah, he has. So guys, if you have a look at it, you'll see that there are some questions that have been answered by Joe, and they're really good questions as well. So all right. Thank you very much, Tatum. It's been my pleasure.